So, welcome to the explanations to the short computer quiz we took the other day. So we know which ones we've got right or wrong. So if you got it right, there's no need to listen to me explain what it is. You should be able to fast forward through all the ones you got correct and just go straight to the ones that you missed. And then I'm going to provide an explanation of how to do the problem. Hopefully without giving away the answers. Some of them it's hard and I kind of have to give away the answer. But I'm going to try not to. I'm going to try to just tell you how to do it or demonstrate how to do it, and then so you can figure out how to get the right answer. What I need you to do is go ahead and complete all the ones that you got incorrect, and then turn that into me. You'll have a hard copy of the same test that you took online. So just complete all the ones that you got incorrect, show all of your work for full credit, and then that is what will go in the grade book. If you do that, you should get a good grade. So here we go. Okay, we start out with number one. Brandon wonders if people get gray hair as they get older. What is the dependent variable? So in functions, in function notation, we've been talking about linear equations and functions lately. There's always going to be an independent and a dependent variable, also known as inputs and outputs. We refer to it as the domain and the range as well. But in this case, dependent and independent are pretty much what they sound like. If you think about it, does gray hair depend on the age of the person, or does the age of the person depend on gray hair? I guess they do sort of depend on each other, but the aging happens and then the result is the gray hair. Okay, typically that's the way it works out. There's not too many babies born with gray hair, and there's not too many children with gray hair. Typically the aging is going to happen, and then the result will be the gray hair. So the result, the thing that, so the gray hair is sort of depends on the aging happening. So just take that for what it is. Pretty much gave away the answer, but yeah, so that's dependent and independent variables. We'll go ahead and go to number two. See if we can fit it all on the screen here. Okay, I think we can. Okay, so number two. Wow. Okay, number two. Studies have shown a positive relationship between reading and test scores. What is the independent variable in that relationship? So, just as an aside here, we haven't talked about positive and negative relationships, but I'm going to demonstrate sort of how they look on a graph while we answer this question. But all they really want to know is what is the independent variable. Okay, so again, you know, the reading happens and then the result is that test scores change. You know, you can the reading actually in this case, you're independent. You can decide to read books or not to. So that's something that could happen or could not happen. But once it does, once you read enough books, your test scores are going to change. If you don't read books, your test scores are probably going to remain roughly the same. So the test scores sort of depend on you reading, but you reading, you can choose to read or not to read, and that makes you sort of independent. Okay? Now, typically the independent variable is always going to be on that axis of a graph, if we were to graph this, and the dependent variable will be on this axis, okay? So, which is the y, or the x and the y normally when we graph things. So if this happened to be number of books read, but we'll leave off read, and this is test scores, okay? A positive relationship as you read, so that's 1 book, that's 2 books, 3 books, 4 books, 5 books. Obviously, as you read more books, you're going to do better on tests. So that's what a positive relationship looks like. It slopes up from left to right. Okay? So hopefully that's enough to answer that one. As far as hopefully you're getting the idea of independent and dependent variables. The best way to establish which one is which is the independent and which is the dependent, is just figure out, which one would not change unless the other one changed. Okay? And that's always going to be your dependent variable. There's something that wouldn't change if the other one didn't change. In this case, the test scores are not likely to change if they're not reading any books. Well, then that makes your test scores the dependent variable, and the reading the number of books your independent variable. I just gave that one away, but that's okay. So anyway, that's number 2. Number 3, studies have shown a negative relationship between the number of times we eat out and the amount of money we save. What is the dependent variable, and what is the dependent variable? So if we did not change our eating out habits, would the amount of money we save change? No, probably not, unless we change something else. But we're just talking about eating out. That's it in this scenario. So the saving of money is the thing that would not change. It changes as a result of something else changing, our amount of eating out. So we can choose another one where you can say you're independent in your choice as to whether to eat out or not eat out. So hopefully that sort of answers your question. And the amount of money you save kind of depends on how much you eat out or do not eat out. Okay? But the way this looks, if we were to graph it, this is always going to be, we'll just label our axes as X and Y, just kind of get used to that, but they don't really have to be if we're just graphing it like this. We'll say number of times, and I'm going to do this really quickly, number of times eat out, and then money saved. Okay, so the number of times eating out and money saved. Well, as you eat out more, you're going to save more money, correct? Excuse me, I'm sorry. Obviously, if you eat out more, you're spending money, so you're saving less money. So let's say that you're eating out 0 times, 0 here, and you're saving a certain amount of money every month by eating out. Who knows what it is? It could be anything. But it's a certain amount by eating out 0 times. Well, each time you eat out, 1, 2, 3, 4, 5, you're spending money, and when you spend money, you are by definition not saving it. So the amount that you save is going down as you eat out more and more times. So that's a negative. That's the graph of a negative. You can see it slopes down from left to right. So that's a little extra. You can answer the question without the graph, but you need to start getting used to the graph as well. All right, on to number 4. Okay, so which answer choice shows the correct f of x, that's how you say that, f of x values for the function rule f of x equals negative 3x plus 3 when x equals negative 2, 0, and 4. Okay, so f of x is essentially, it's just a different way to say the output, or it's just the result of when we plug different things in for x, and when you plug things in, that's your input. So it's basically your output. So what they are asking is, if we plug this in for x, what does this side of the equation equal, which is going to give us f of x. So they just want us to plug each of these in and see what it spits out. They want us to use these things as inputs and see what output we get. So let's just try one. So we will say, we'll just put equals because we won't write f of x right now. But we'll put -3, but instead of x, we will substitute in this -2. Okay? We substitute in the -2 plus 8. So that is this equation, but instead of x, we've just substituted in -2. Well, a negative times a negative is a positive. Okay, so -3 times -2 is +6. Okay, so we just write it below it, plus 8. 6 plus 8 equals 14. So our first sort of result is when we input -2, we got out 14. Well, let's look at our answer sets. I only see one 14 period, and it's right there. So automatically we know it's C, but let's just check just to make sure that when we plug in 0, we'll get 8 like it says we should. So we don't even have to write that. We see this right here. We see this x. We know -3 times 0 is 0. That's going to leave us with 8. We don't even need to write that out. We know that's correct. Therefore, we know C is correct. I gave that one away. But I think that's okay for the first one. Some people we were still kind of struggling with this one, so that's fine. Okay, which of the following is the correct domain and range for the information table? Okay, so this is what we need to know. We need to know that the independent variable, typically, I'll just abbreviate that, independent, the input to our function, and the domain are talking about the same thing, okay? Which is always denoted by x. They're always the variable x. Well, not always, but typically denoted by x. If we're working with x and y, x is always your input, and y is always your output. X is always your independent variable, y is always your dependent variable when you're working with x and y. I don't know that's not a law of the universe, that's just something that we do in mathematics. So which of the following lists the correct domain and range? Okay, well, if we know that our domain is our x's, in this case, years, I think we just about answered the question then. The range is the outputs. It's all of the outputs. So this is sort of all of our inputs, and this is kind of all of our outputs. So we can look down at our answers, and basically the domain is all possible inputs. Well, we have the inputs stated here, and the I don't know if I said that right, the domain, I hope I said domain and not range, is all the possible inputs. Well, the range is all the possible outputs. So we can see one of these corresponds directly to how I've explained that. It should contain exactly what is shown in the chart. And hopefully you can answer that from that. We'll go ahead and put, down here, the dependent variable, which is also your output, which is your range, and that is associated with y, the variable y. So, and that is always going to be that way. So hopefully that's enough to answer that one. All right, so number 6, which of the following answer choices contains the correct f of x values for the function table to the right? Okay, so this is our function right here, okay? X is our input or independent variable, or the domain is all the different x's we put in, but this is our output. So our x is our input, but the f of x is our output. So again, all they want us to do is just rewrite. So I'll just go ahead and say something equals 2x minus 12. And they just want us to plug in these different x values and see what we come up with. So I'm going to go ahead and just plug in -2 right here instead of x. I'll just write 2 times -2. So -2 is taking the place of x, minus 12. I'm going to evaluate that. So hopefully you can do the math on that one. Remember, a positive times a negative. This positive right here times this negative is a negative. Okay? So I'm going to leave you to work the rest of that one. So 2 times -2 is -4, and then you have minus 12. That gives you some certain number. And then so you can continue to just rewrite, 2 parentheses. So I'm going to plug in -1 right here. I'm going to have minus 12. And then so you see if you get your next number, looks like you should probably have to do at least 2 of those. And hopefully that's enough to go ahead and answer that one. Okay, so one thing we're going to do, make this a little smaller so we can see it. Which equation gives the rule for the function table? So this time they're actually giving you the inputs and the outputs. So what they're saying is there's some equation down here, or there's some expression right here. Okay, any of those, we don't know which one, but when we substitute these values, like when we substitute 1 into any of these right here, it will equal 3 over here. Okay? That's what they're saying. So we just have to pick, we have to just plug and chug. So I'm just going to pick one. Hopefully it's not the right one. We'll see. Actually, okay, I'll pick the last one. I'll pick D. It's probably not going to be D. So we're just going to say, well, whatever we're looking for, our f of x, okay, if f of x, that's what we're looking for, equals x squared plus 2, well, we just need to evaluate. We'll just put equals, because we're looking for f of x. So let's say we plug in 1. For x, it's 1 squared plus 2. It actually does equal 3, because 1 times 1 is 1, plus 2 is 3. Okay? And we would just do the same thing. So that's one that we just did there. We would just do another one. We would say equals, but instead of 1, now we're going to plug in 3. And it's going to be plus 2. Okay? So you know how to do 3 squared, square a number and add 2. Maybe you'll come up with the next one. I don't want to give too much away. Maybe I happen to pick the right one, but anyway, hopefully it's the same thing in all these. You just plug these values right here in for these x's, and then do all this other stuff. Do all this stuff to them, and that's it. And that will give you a number. Okay, so, and then that is what your f of x will be. It will give you a value. So hopefully that's enough to answer that one, if you were confused on that one. Okay, again, let's make this one a little smaller. Okay, so which statement is true about the following graph? Well, we can see we have tree growth. So they're looking at a tree and they're logging the time in years, and they're seeing how tall the tree grows, and that's actually how it works. As the years go by, trees grow taller. So we've got some statements down here, and we have to figure out which one's true. So A, time is the independent variable. B, height is the dependent variable. C, the domain is given in years. And D, all of the above are correct. Well, so does the height of the tree depend on time? Yes, it does. Now, does time depend on the height of the tree? Well, time actually doesn't depend on anything. Time just happens. I guess it depends on the universe being created maybe, but time doesn't depend on anything. It happens, and it happens at the same, it just happens. And well, it actually doesn't happen at the same rate everywhere. We definitely won't cover that in this class. So that's probably enough to maybe give it away, at least establish what is the independent variable and what's the dependent variable. Obviously, a tree needs time to grow. It depends on having time pass by in order to grow. We know that. The domain. Well, we know that the domain is the values of the output. We know that the output is typically associated with the dependent variable, the domain. They're actually very easy to confuse. Back up, forget I said domain. The domain is always the inputs, okay? The way I like to think about, just really quickly to sort of like, the way I try to remember domain and range is which, okay? Let's say that you are a little stick figure here, and you are shooting arrows. You're shooting bow and arrows, and you have targets down here, okay? Well, everybody knows what a shooting range is, okay? Well, you hang out in your domain. I don't know if you've heard that, but like your house is your domain. That's your domain. That's where you sort of hang out around in here, okay? Well, if you're shooting arrows, shooting little arrows out through here, you're shooting them down range. So you're doing something, okay? But once you release the arrow, it's gone and it goes down the range. So you sit in your domain and shoot down the range. So the domain in this case is like the thing that you do, and then so we do something, we decide whether or not to shoot an arrow, which would be sort of analogous to the independent variable. But once it's gone, it has to go where the laws of physics demand that it goes. So it has no more choice. It is dependent on how well we aimed and where we shot and all that stuff. So it's kind of how I like to remember that. So this is sort of your domain, and you can shoot these little arrows down range. And at the end, this is sort of your result down here. Okay? So the domain is given in years, domain associated with the input, which is associated with the independent variable. We've established that time is the independent variable, so indeed, that should be enough maybe to answer this question. So if it's not, feel free to ask me in class. Okay, so 9. Which statement is true about these ordered pairs? So we have several ordered pairs, and let's see. Um, well, if you don't know, okay, ordered pairs come in one way and one way only. They come in X and Y. That is the way they come. They come in input and outputs. Okay? So input, output, probably couldn't get any messier than that. That is the way that they come. Every time you see an ordered pair, it's X, Y. That's it. So some things we already know. X is associated with the independent variable, which is associated with the domain. Y is associated with the dependent variable, which is associated with the range. So by looking at that, I think we should be able to figure out which ones we need to pick here. So they're asking us, range, output, okay. Yeah, hopefully we've given you enough. You can back up to question 8, and if you got that one right, I'll also do a little thing on domain and range and how one way to remember them. But anyway, hopefully that should be enough to answer that one. Okay, identify the ordered pair that is not a solution to f of x. That's how we refer to that, but it's basically just our output. And then this is our expression that determines our output. So that's our output, that's the expression that determines our output from putting in inputs or substituting in different values for x. So identify the ordered pair that is not a solution to that. So evidently several are. So all you do is you're going to plug this number, your first number in your XY pair, your XY ordered pair. So we're given a 2, so we're going to plug in -4 times 2 plus 3. That's going to give us a certain number. Does it equal this number? When we do this operation right here, does it equal this 5? Okay, and you do that for every one of these until you find one that it does not. Because it says identify the ordered pair that is not a solution. So evidently they're all, I'm not going to do these for you, they're all solutions with the exception of one. So you have to find one instance where you plug in that first number, your x, where you plug in one of these and your function does not spit out this y, our second number in the ordered pair. Okay? And that's going to be your answer. Okay, so which statement is true? This number on the number 11, which statement is true about the values in the mapping to the right? Okay, so this is sort of you can kind of think of it as, actually I've already done an analogy. If think back on maybe number 9 possibly, something like that, 8 or 9. But anyway, it's heading, these mappings, basically what this little illustration here is saying is you take this number, you do some stuff to it, which is what this arrow represents, some stuff. You could add to it, you could multiply something by it, you could subtract from it, you could do all kinds of things, but you wind up with this. So basically that's your input. So you set up a series of multiplication or addition or subtraction, and then and you'll have a variable in, and you plug this 2 into it, and when you do, it spits out -4. Okay? So that's just it, but it goes in that direction. Okay, from the -2 to the -4 by way of sort of doing things to the -2. So let's read some of the things. Which statement is true about the values in the mapping to the right? So -2, -1, 0, and 1, and 2 are the independent variables. Okay, well, looks like this guy has no choice. Looks like he depends on all this stuff that's done to convert this into this. So this looks like more like they don't have much choice over here. They're dependent on what goes on over here. Okay. -2, -1, 0, 1, and 2 are the output values. Okay. I'll let you decide that for yourself. -2, -1, 0, 1, and 2 are the range. Well, I'll let you decide that for yourself. We know that the domain is actually associated with the what? The independent variable. And the range is associated with the dependent variable. So I will let you decide. Hopefully that helps out on that one if you got it wrong. Okay, so which equation states the rule for the function to the right? Okay, same thing. We've been here before in several other problems. All we do is we just start plugging in. So we pick this first one, we say 2, but instead of this x, we're going to plug in an x value, -2, okay, -2, and we're going to see what that equals. We're going to see what that puts out. So we put something in, our x, our input, and then it's going to put something out, our output, okay? In this case, 2 times -2, it's going to be -4. The positive times the negative is negative. -2. Well, this is all heading in the negative direction if we can remember how our integers work. So -4 -2, it's just all in the negative direction. -6. Okay? So we put this in, and using this one, we got -6. We did not get -2. So that one appears like it does not work. So we just go on to substitute in values, and so we would substitute in, I'll get you started on maybe this next one. We would substitute in -2 plus 4. We would try that, and if all that equaled this, equaled this -2, then we would be on to something, and then we would probably go ahead and plug in this -1 in for the -2, or for the x, So we would try, let's go ahead and try the -1 plus 4 equals something. If it equaled this 1, we would really be on to something. So you just have to plug these in and see what it equals, and if it equals this other one, then it is the rule that is used to determine these inputs give you these outputs. Okay? So I think that's about it. Hopefully that's enough to get you through this one. But if you have questions, just raise your hand. We're going to do this a lot of this in class, hopefully. So just raise your hand and I'll help you out. All right.